The cosmos is all that is or ever was or ever will be. Our tiny planet drifts between immensity and eternity, a fragile home in a vast universe. Yet we are curious, brave and driven to explore. Every atom in our bodies was forged in the heart of a distant star. We are stardust. To understand the universe is to understand ourselves. Let us cast off from Earth and set sail on the cosmic ocean, seeking answers to the deepest questions. This journey requires only one thing, from you an open mind and a sense of wonder. To cross the universe, we need more than rockets, we need a ship of the imagination. Powered by science and curiosity, it can take us anywhere, anywhen. Our tools, telescopes, spectrometers, supercomputers are its instruments. Step aboard and see Earth shrink to a fragile sphere in the darkness. From this vantage, our divisions seem small, our shared destiny clear. The journey begins now. Our first lesson, humility and perspective. Our journey spans both space and time. Looking at the stars, we look back in time. Light from Andromeda began its journey millions of years ago. We'll rewind to the Big Bang, witness the birth of stars and galaxies, and follow the elements that make up life. We'll tour the Milky Way, visit our planetary neighbors, and return to Earth with new eyes. This is the story of where we came from and where we might go. The cosmos is our greatest adventure. It is our story. Our journey begins at the very beginning, 13.8 billion years ago. All energy, matter, and space were compressed into a single, hot, dense point. The Big Bang marked the birth of our universe. Time and space began. As the universe expanded and cooled, the first building blocks of matter formed. For every billion pairs of matter and antimatter, one extra particle of matter survived. That tiny remnant became everything we see today. You, me, the stars, we are all survivors of that great annihilation. This is the ultimate origin story. In a fraction of a second, the universe underwent cosmic inflation, expanding from smaller than an atom to larger than a galaxy. Tiny quantum ripples became the seeds of galaxies. As expansion slowed, the universe was a hot, dense plasma, no atoms, just particles colliding in a glowing haze. About 1 second after the Big Bang, quarks formed protons and neutrons. In minutes, these fused into hydrogen and helium nuclei, the universe's raw materials. For hundreds of thousands of years, the universe remained a foggy soup, light trapped within. The cosmos was bright, but no stars yet illuminated the darkness. This was the universe's dark ages. For 380,000 years, the universe expanded and cooled in darkness. For the first time, stable neutral atoms could form. This event is called recombination. Suddenly, the photons, the particles of light, were free. With the electrons now bound in two atoms, the cosmic fog lifted. The universe became transparent. This first light, released all at once from every direction, began its long journey through the cosmos. That ancient light is still all around us. It is the oldest light in the universe. The cosmic microwave background, or CMB. It is the most distant thing we can possibly see. A baby picture of the universe. There are tiny variations in its temperature, the seeds of everything to come. After the initial light, the universe entered the cosmic dark ages. There were no stars, only vast clouds of gas drifting through the darkness. For millions of years, gravity shaped the cosmos. It pulled matter together, forming vast filaments of gas. The universe began to form a cosmic web. Inside these clouds, gravity compressed gas, causing it to heat up. Eventually, nuclear fusion ignited, and the first stars were born. These giants ended the Dark Ages. Their light reionized the universe, exploding as supernovae. They seeded the cosmos with heavy elements, the building blocks for future planets and life. The cosmos is not an empty stage. It is filled with vast ethereal clouds of gas and dust. These clouds, known as nebulae, are the birthplaces of stars. They drift silently through the interstellar medium, enormous reservoirs of the raw materials left over from the Big Bang, mostly hydrogen and helium. These stellar nurseries are some of the most beautiful objects in the universe. They glow with vibrant colors, illuminated from within by the brilliant light of the young stars they have already created. Imagine colossal sculptures of cosmic smoke, painted with hues of pink, blue, and gold. These are not just pretty pictures. They are active construction zones for new suns and new worlds. Gravity is the master architect in these celestial workshops. Within these giant clouds, which can stretch for hundreds of light years, regions of gas and dust begin to clump together. A passing shockwave from a distant exploding star, or the gentle gravitational nudge from a nearby star, can be enough to start the process. A small dense knot of material forms. Its own gravity grows stronger, pulling in more and more surrounding gas and dust. This process is slow, taking millions of years. As the clump collapses, it begins to spin, flattening into a rotating disk. At its center, a dense hot core begins to form. This embryonic star is called a protostar. The protostar is not yet a true star. It glows, but not from nuclear fusion. Its light comes from the intense heat generated by the gravitational collapse. The core continues to shrink, and the pressure and temperature skyrocket, reaching millions of degrees. All this time, the surrounding disk of gas and dust swirls around the growing protostar. This is the protoplanetary disk, the birthplace of future planets, moons, and asteroids. We see these disks around young stars throughout our galaxy. They are the evidence that the formation of planetary systems is a common and natural outcome of star birth. Our own solar system began in just such a way billions of years ago. Finally, a critical threshold is reached. The temperature and pressure in the core become so extreme that nuclear fusion ignites. Hydrogen atoms, the most abundant element in the universe, are slammed together with such force that they fuse to form helium. This process releases a tremendous amount of energy, the same process that powers our sun. This energy pushes outward, creating a pressure that perfectly balances the inward crush of gravity. The collapse stops. A star is born. It emerges from its dusty cocoon, its newfound light blowing away the remaining gas and illuminating the nebula for all to see. A new sun has joined the cosmic dance. Once a star is born, it enters a long period of stability called the main sequence. Our sun is halfway through this phase, steadily fusing hydrogen into helium. A star's life balances gravity, which crushes inward, and outward pressure from nuclear fusion. A star's mass determines its destiny, dictating its temperature, color, brightness, and lifespan. Low-mass stars burn slowly and live for trillions of years. High-mass stars burn fast and live for only a few million years. As stars age, they fuse heavier elements. This process, stellar nucleosynthesis, creates elements like carbon, oxygen, and iron. These elements were forged in the heart of a star. We are stardust, brought to life. All good things must come to an end, and so it is with stars. Their death, like their life, is determined by their mass. For a star like our sun, the end is relatively gentle. The outer layers of the star drift away into space, forming a planetary nebula. At the center, the hot, dense core remains, called a white dwarf. A white dwarf no longer produces energy and will eventually cool down completely. For the most massive stars, the end is anything but peaceful. It is the most violent and spectacular event in the universe, a supernova explosion. This explosion is a moment of both destruction and creation, scattering heavy elements across the galaxy. What is left behind is the collapsed core, which will become either a neutron star or a black hole. Stars do not live in isolation. They are bound together by gravity into immense systems called galaxies. A galaxy is a sprawling, majestic city of stars, gas, and dust. Our own star, the Sun, is just one of hundreds of billions of stars in our home galaxy, the Milky Way. When you look up at the night sky and see that faint, milky band of light stretching across it, you are looking into the dense, crowded plane of our own galactic disk. For most of history, we thought this was the entire universe, but we were living on a single island of light, unaware of the vast ocean of darkness and the countless other islands it contained. Galaxies come in a beautiful variety of shapes and sizes. There are grand spiral galaxies like our own Milky Way and our neighbor Andromeda. These have majestic sweeping arms of young blue stars and glowing pink nebulae spinning around a bright central bulge of older, yellower stars. Then there are elliptical galaxies, which are huge, featureless balls of old stars. They are like cosmic retirement homes, where star formation has long since ceased. And there are irregular galaxies, smaller and more chaotic, with no defined shape, often the result of galactic collisions or interactions. Each of these islands of light is a universe in itself, with its own history and its own stellar population. Galaxies are not static, they are dynamic, evolving structures. They grow by merging with other galaxies. Over cosmic time, smaller galaxies are pulled in and cannibalized by larger ones. Our own Milky Way is currently in the process of consuming several smaller dwarf galaxies, and in about 4.5 billion years, we are set for a major collision. Our galaxy and the Andromeda Galaxy are hurtling towards each other and will eventually merge to form a single, giant elliptical galaxy. This cosmic dance of gravity shapes the structure of the universe on the largest scales, building ever larger structures from smaller beginnings. And galaxies themselves are not scattered randomly through space. They are organized into even larger structures. They are grouped into clusters, and these clusters are linked together into superclusters. These superclusters are arranged in long, thin filaments surrounding vast, nearly empty regions called cosmic voids. The universe, on its grandest scale, looks like a gigantic glowing web, the cosmic web we saw seeded by the tiny fluctuations in the early universe. The galaxies are the bright beads strung along the filaments of this web. They are the builders of the cosmos, the places where the drama of stars, planets, and perhaps life unfolds across billions of light years and billions of years. Our cosmic journey now takes us to the most extreme and mysterious objects in the universe, black holes. A black hole is an immense amount of matter crushed into an infinitesimally small space. The gravity is so powerful that nothing, not even light, can escape. Anything that crosses the event horizon is lost forever. What happens at the center? We do not know. We have even managed to take a direct picture of a black hole's shadow. Supermassive black holes lurk at the center of nearly every large galaxy, including our own Milky Way. They are fundamental players in the grand cosmic story, and yet they remain wrapped in profound mystery. We have explored the stars and the galaxies, but what if all this visible matter is just the tip of the cosmic iceberg? What if the true universe is mostly invisible? Galaxies are spinning so fast that the gravity of their components shouldn't hold them together. This mysterious invisible substance is called dark matter. It's a cosmic ghost passing right through us. Dark matter outweighs all the visible matter in the universe by more than 5 to 1. All the stars and galaxies are just a sprinkle of cosmic dust on a vast unseen scaffolding. Dark matter is the silent architect of the cosmos. But what is it? The leading hypothesis is that it is made of some new kind of subatomic particle. Finding it would revolutionize our understanding of physics. The universe is expanding. We have known this for nearly a century. We expected that the combined gravity of all the matter in the cosmos would be slowing this expansion down. Gravity, after all, pulls things together. For decades, astronomers tried to measure this rate of deceleration. They used distant supernovae as standard candles to measure cosmic distances and look back in time. They expected to find that the universe was expanding faster in the past than it is today. But in the late 1990s, they found the exact opposite. The expansion of the universe is not slowing down, it is speeding up. This was a shocking, Nobel Prize-winning discovery. Something is pushing the universe apart. Something is acting against gravity, stretching the fabric of space-time itself at an ever-increasing rate. This mysterious repulsive force has been given a name: dark energy. It seems to be a property of space itself. As space expands, more space is created, and with it, more dark energy. This creates a runaway effect, causing the expansion to accelerate. This is a completely new and unexpected component of the cosmos, and it is the most dominant one of all. It makes up nearly 70% of the total energy density of the universe. Think about what this means. All the matter we know, the stuff of stars and planets, makes up less than 5% of the universe. Dark matter, the invisible scaffolding, makes up about 25%. The rest, the vast majority of the cosmos, is this strange dark energy. We are living in a universe that is dominated by substances we do not understand. Our cosmic journey has led us to a place of profound ignorance. We have peeled back layers of the cosmic onion only to find that its core is a complete mystery. The discovery of dark energy has fundamentally changed our picture of the past, present, and future of the universe. What is dark energy? We have no idea. It is an even deeper mystery than dark matter. Is it a new fundamental force of nature? Is it the energy of the vacuum, a cosmological constant as Einstein once proposed and then discarded? Or is our understanding of gravity itself, Einstein's theory of general relativity, incomplete on the largest cosmic scales? Whatever it is, its implications for the future are staggering. If it continues to accelerate the expansion, then distant galaxies will eventually be pushed away from us so fast that their light can no longer reach us. They will disappear beyond our cosmic horizon, leaving our galaxy alone in an endless empty void. Our exploration of the cosmos reveals a humbling truth. The more we learn, the more we realize how much we do not know. The mysteries of black holes, dark matter, and dark energy are not small details. They represent the dominant components of our universe, telling us that our current understanding of the cosmos is, at best, incomplete. What other mysteries lie hidden in the deep? The quest to understand the universe is one of the noblest and most deeply human adventures. The journey is difficult, but the reward is the greatest prize of all, a true understanding of the cosmos and our place within it. After journeying through space and time from the Big Bang to dark energy, it is time to find our place in this immense cosmic tapestry. So, where are we? What is our address in the universe? We live on Earth, the third planet from the Sun, part of a family of 8 planets. Our solar system is in the Milky Way galaxy, in a quiet spiral arm, about 2/3 of the way out from the galactic center. The Milky Way is part of the Local Group, which is part of the Laniakea supercluster. This address tells us we are not the center of anything. The universe does not revolve around us. Instead, it should fill us with a sense of wonder and connection. We are part of this immense cosmic structure. Having established our address, let us zoom back in on our home. Let us look at Earth from a distance. From the edge of our solar system, our planet appears as a tiny point of light, a pale blue dot suspended in a sunbeam. On this tiny speck, everything that has ever happened in human history has unfolded. Our world is a fragile and lonely outpost in the great enveloping cosmic dark. Earth is located in the habitable zone, not too hot and not too cold. It is just the right distance from our sun for liquid water to exist on its surface. Our planet is a water world, a blue marble covered in vast oceans. Earth has other features that make it a haven for life. It has a substantial atmosphere that keeps the planet warm, provides the oxygen we breathe, and protects us from incoming meteoroids. This perspective should fill us with a sense of profound appreciation and responsibility. That's us. The Earth is the only world known so far to harbor life. It is our only home. Preserving and cherishing this pale blue dot is a responsibility that falls to all of us. Our cosmic journey reveals a universe of countless stars and galaxies. Telescopes have shown planets are incredibly common, orbiting most stars. It seems almost inevitable that we are not alone. But if the universe is teeming with life, as physicist Enrico Fermi questioned, where is everybody? This is the Fermi paradox. Despite decades of listening, we've heard only cosmic silence. This silence is a profound mystery. The search continues, driving scientific exploration. Finding life elsewhere would redefine our place in the universe. Until then, we are the only known voice in the cosmic ocean. For nearly all of human history, our journey to the stars was one confined to our minds. We were bound to the surface of our world, feet planted firmly on the ground, but our imaginations were free to roam. The stars were a source of endless wonder, a canvas for our myths and stories. The sky was our first calendar, our first map, and our first storybook. This deep and ancient curiosity was the seed of science. It was a road that would eventually lead us from simply looking at the stars to actually touching them. The dream of flight, of breaking the bonds of Earth's gravity, is an ancient one. Mastering the air was a monumental achievement, but the cosmos still remained tantalizingly out of reach. The dream of flight evolved into the dream of spaceflight. The rocket unlocked the door to the cosmos. Born of war, destined for exploration, humanity poured resources into spaceflight. The journey was perilous. On October 4th, 1957, that dream became a reality with Sputnik 1. The years that followed were a whirlwind of astonishing achievements. Yuri Gagarin circled our planet. He saw our world as a single unified home. We were citizens of the cosmos, passengers on spaceship Earth. The ultimate goal was the moon. The Apollo program was humanity's cathedral to the stars. Neil Armstrong and Buzz Aldrin took their first steps onto the lunar soil. It was a giant leap for all of humankind. While our robotic probes explore our solar system up close, our greatest tool for understanding the wider universe has been the telescope. These magnificent instruments are our time machines. They collect the faint ancient light from distant stars and galaxies, allowing us to peer deep into cosmic history. For centuries, our view was limited by the blurry, turbulent veil of Earth's atmosphere. To see the universe in all its glory, we had to rise above it. In 1990, the Hubble Space Telescope was carried into orbit. It was our first major eye in the sky, a clear window onto the cosmos. Hubble revolutionized nearly every field of astronomy. Hubble showed us the universe with unprecedented clarity and beauty. It delivered stunning images of stellar nurseries, where new stars are born, and the ethereal shells of dying stars. It helped us to pin down the age of the universe by measuring the rate of its expansion. It provided the first visual evidence for the existence of supermassive black holes at the centers of galaxies. Its deep field images, captured by staring at a tiny, seemingly empty patch of sky for days on end, revealed thousands of previously unknown galaxies, stretching back almost to the beginning of time. Hubble brought the wonders of the cosmos into our homes and into our hearts. Building on Hubble's legacy, we have launched a new generation of space observatories, each designed to see the universe in a different kind of light. We have telescopes that can detect high-energy X-rays from black holes and exploding stars. We have instruments that can see in infrared light, allowing them to peer through the dense dust clouds that hide newborn stars and to see the most distant ancient galaxies. The most powerful of these is the James Webb Space Telescope. Its giant golden mirror allows it to see the very first stars and galaxies switching on at the dawn of cosmic time, and to sniff the atmospheres of planets orbiting other stars, searching for the chemical signs of life. These great observatories are more than just machines. They are monuments to human curiosity. They are the physical embodiment of our desire to know our origins and to understand our place in the universe. The data they collect is shared with scientists and the public all around the world, fostering a global community of discovery. The knowledge they provide helps us piece together the grand narrative of the cosmos. From the Big Bang to the present day, these telescopes are our silent, tireless explorers sailing the cosmic ocean of light and bringing back stories of wonder from the farthest shores of space and time. Our journey to the stars is far from over. In fact, we may be on the cusp of a new golden age of exploration with a new generation of rockets and spacecraft. The dream of regular citizens traveling to space is becoming a reality, promising a wave of innovation. The moon is calling to us again. This time we plan to stay and to test the technologies we will need for even more ambitious journeys. Sending humans to Mars is the next giant leap for our species. To find life on Mars would forever change our perspective on our own place in the universe. The stars are not just our destination, they are our destiny. Our grand tour is coming to an end. We have journeyed across cosmic history, from the fiery birth of the universe to the silent sprawling galaxies of today. We have sailed through stellar nurseries and past the event horizons of black holes. This journey has shown us a universe far more vast and magnificent than our ancestors could have ever dreamed. The most powerful lesson is that the universe is knowable. The cosmos follows laws of nature that we can discover and understand with science. This quest for knowledge is fueled by our innate curiosity. Today, we have the immense privilege of living in an age where we can do more than just wonder. It is a testament to the power of the human intellect and our unyielding spirit of exploration. And yet, we have only just begun to scratch the surface, waiting for the next generation of explorers, scientists, and dreamers. Our cosmic perspective gives us more than just knowledge, it gives us wisdom. When we see our world from the vantage point of space, a tiny, fragile oasis of life in the vast darkness, our terrestrial squabbles seem to fade into irrelevance. From out there are no borders, no divisions between nations or peoples. There is only one Earth, a single interconnected ecosystem that we all share. This perspective, the overview effect, is perhaps the most important gift of the space age. It is a profound reminder of our shared humanity and our shared destiny on this one small planet. We are all in this together. This journey through the cosmos brings us back home, to this pale blue dot. We have seen the fiery chaos of Venus and the frozen barren plains of Mars. We have learned how rare and precious a world like ours might be. It is a world with liquid oceans, a breathable atmosphere, and a stable climate. A perfect haven for life to flourish. For billions of years, this planet has nurtured life. Now that life, in the form of us, has become conscious of the universe. We are the means for the cosmos to know itself. This is a remarkable and humbling realization. It bestows upon us a unique and profound responsibility. We must be the caretakers of this world. Our science, the same tool that has revealed the wonders of the universe, also shows us the impact we are having on our home planet. The delicate balance that makes Earth a habitable world is being disrupted by our actions. The future of our civilization and the health of our planet are in our hands. The cosmic perspective urges us to think beyond our immediate needs, to act as wise stewards for future generations. Protecting our planet is not just an environmental issue, it is a cosmic one. It is our duty to preserve the only known outpost of life in the universe. So, let us continue to look up in wonder. Let us support the scientists, engineers, and explorers who are pushing the boundaries of our knowledge. Let us invest in the quest for understanding, for it enriches us all. But let us also look down, with a newfound sense of awe and reverence for the world beneath our feet. Let us use our cosmic knowledge to cherish our home, to solve our problems, and to build a future worthy of our place in the cosmos. The story of the universe is our story, and the most important chapters are the ones we have yet to write, here on Earth.